Hello everyone, in this video we will solve one of the problems of maximum power transfer theorem, that is from the Boylestad book. So here they are asking you the value of RL for maximum power to the load and find the maximum power to the load. So we have to find the value of the resistance and also we have to find the value of the power, that is the maximum power. So you know that in the maximum power transfer theorem, the maximum power is transferred to the load, that is RL, when RL is equal to the Thevenin's resistance. That means RL should be equal to RTH. Okay. Now we have already solved many problems on the Thevenin's theorem, like finding out the Thevenin's voltage, or it might be the Thevenin's resistance. So to find the Thevenin's resistance of this particular circuit, what you have to do is first you have to remove the load resistance from the circuit. Okay, you have to remove the load resistance from the circuit and you have to short the voltage source and you have to open the current source. That means the independent sources are being removed from the circuit. Okay, so now you are going to have 3 ohms here, 10 ohms here and here 2 ohms. Okay, so RTH will be equal to now the sum of resistances because these resistances are in series. So now this is equal to 15 ohms. So RL should be equal to 15 ohms. Now to find the maximum power, okay, that is equal to ETH square divided by 4 into RTH. Okay, so this is the value of the maximum power. So now to find out ETH, okay, how are you going to find out the ETH value? Okay, find out the ETH value. So this will be, we can say this is, if you have current source like this, it will be like this, right? So now you have a voltage source. So now I am converting this parallel combination of the current source and the resistance to the series voltage. Okay, so 6 into 10 is 60 volt. This is 10 ohms. This is 3 ohms and this is 68 volts. This is 2 ohms. So here you are going to find out the ETH. Okay, ETH will be now like this, something like this. So this value will be equal to 68 plus 60. That is ETH will be equal to minus 128 volts if you are taking in this direction. But here if you are going to take, that will be 128 volts. Okay. So ETH will be equal to 128 volts. So now 128 square divided by 4 into what is your RTH? RTH will be equal to 15. Okay, so what is the value of this? You can find out the value of that. So that is 128 square divided by 60. It is equal to 273 watts. Okay, so that is equal to 273. So this is all about this problem.